Here is the final question of the compulsory part. A body of mass 2.5 kg is suspended by two light inextensible strings, XP and YP, which are inclined at 40 degrees and 50 degrees respectively to the downward vertical. Find the tensions in both strings. So you have to take the gravity to be 10. So here is how the diagram will look like. So you have XY being the distance between the two strings, horizontal distance between the two strings, then P, the point at which the mass of the object is held, so 2.5 kilograms, as you can see. Okay, so the 40 degrees and 50 degrees for XP and YP respectively. So XP, okay, XP, this is X and this is P. So the angle between the vertical downwards, okay, the downward vertical and the XP, the angle between them should be 40 degrees. So this 40 degrees, and the vertical downward as well, and the YP, the angle between should be 50. So that's 50. Since this is vertical, that means this is a quadrant. So you have 90 degrees. So in order to get this angle, the complementary angle will be 90 minus 50, which will be 40 degrees, and the same as well here. So in order to get this theta, you should be getting 50 plus 40, then you subtract from 180 the sum of interior angle of a triangle. So here should be 90 degrees. So you have 90 degrees for this side. All right, so let's see how to solve this. So first of all, we have to find the two strings, okay, the tension in the two strings here. So here and here. So we use the Lamis theorem approach. So we have, using the Lamis theorem, we'll have the weight, the ratio of the weight to its angle, that is the angle between the two other forces. So you have the weight, okay, to the sine of the angle between the other two forces. So the other two forces are this T sub 1 and T sub 2. So the angle between them, that is this. So you have this, the weight here, the weight, and the other angles are to the left and to the horizontal right. So the angle between them should be the sine for the weight, so the sine theta. So this is the angle here. So it will also be equal to the ratio of the, so let's say we are picking the tension T1, the first tension, so it should be T1 on the ratio between the other two forces, so T2 and W sub M. So the angle between these two, so that will be from here to here. So that is 90 plus the angle here, and the angle here is 40 degrees. Okay, so that is alternating angle. So since it's 40, this will also be 40. This horizontal line, this and this will be parallel. So all right, so here it says 90 degrees plus alpha. So we name this place alpha. So this is alpha. I made this place to be alpha and this to be beta. Okay, so you have, this is the Lamis theorem anyway. Then in order to find the the theta. Okay, the theta here, remember we did it earlier, so we got 90 degrees, so it's directed here to the computation. Okay, so to solve for the T1, first T1, you pick the ratio, you pick this ratio, this, the weight is common to all, so all we have to be alternating is just this and this. So we are looking for T1, we pick this, so that will be this against this. So we have that. So we have the ratio here. So we make T1 the subject. So that will be this T1, that will be the Wm, that is the weight. The weight is 25. That is 2.5 times the mass of gravity. So 25 Newton. So you have 25 sine. Okay, so here you have 130. 90 plus 40, 130. So you have this. N equals to T1. So when you compute that, you get this. Okay, so we do the same thing for the T sub 2. So that's, we pick this against this. So we having this as well. Remember the beta is this, okay, and the beta, this will be alternating with this. So you get 50. And that is what we have here, 50. So we also change subjects and we get this. And we compute this, so we get this. And that is it. So don't forget to like, share, comment. If you have any approach, you can also comment below. Thank you.